Hello and welcome to the video. So in this video, we're looking at how to express functions for like this, where we have something cos something plus something sine something as a single sine or cosine function. So in this question, we're being asked to express 4 cosine of 2 theta plus 3 sine 2 theta in the form of something cosine 2 theta minus something. Now, this might seem a bit weird at first, but basically there's a very logical method of doing these things. You've got to work through the steps one by one, and then they're really not that hard. But I think it's really important to understand the steps. That's the key here. So what I've done is I've written out all the steps one by one, and then we're just going to work through them. So the first thing to do is check whether they want it in the form of sine or cosine, and then write out the formula for that using the addition formulas. So we want it in the form of r cosine 2 theta minus theta, or minus alpha. So we're going to write out the addition formula for cosine. So what I would do here is write that r cosine 2 theta minus alpha would be expanded to r, we just keep the r on the outside of the brackets for now, and then we expand this using our formula, which would be cosine of 2 theta cosine alpha plus sine of 2 theta sine alpha. And this formula you should be given in your formula booklet anyway. And then if we just simplify that out a bit, or expand the brackets, we would have r cos 2 theta cos alpha plus r, oops, not very good, sine 2 theta sine alpha. Okay, so all we've done so far is used a formula to write this. Now we're going to equate the formula that we just worked out to the expression that we were given. So what I mean by that is we're going to take this bit here, the 4 cosine 2 theta plus the 3 sine 2 theta, and I'm going to make that equal to this formula here. So make that equal to all of this. So a lot of writing in these questions, so loads of steps. Basically, that's what we've got. Yeah. And then the really important bit, the kind of clever bit here, is that we can equate the coefficients. So to see what I mean by this, I'm just going to highlight them. So here we have cos 2 theta, and here we have cos 2 theta. So effectively, this 4 is equivalent to this r and this cos alpha. Does that make sense? Like here we have 4 sets of cos 2 theta. Here we have r cos alpha sets of cos 2 theta. Whereas for our other one, this 3 is equivalent to this r and this sine alpha. So we can now equate these. So this 4 must be equal to this r cos alpha. R cos alpha. And then over here, this 3 must be equal to this r sine alpha. And what I like to do is I like to name these. It's kind of like simultaneous equations. I've got this equation and this equation. Yeah, so I've equated the coefficients and I've got 2 separate equations now. And my 2 jobs really are now to find out what alpha is and find out what r is. That's a job of this sort of question. So first of all, I'm going to find the angle by combining these equations. So what I can do is I can take my second equation and divide it by my first equation. So this stuff here, I can do 3, which equals r sine alpha, and I can divide it by all of this. So on the left, I'm going to do 3 divided by the 4. On the right, I'll have the r sine alpha over r cosine alpha. So we've written that. And if you think we can simplify that now, so really my 3/4 is going to equal, well, these r's are going to cancel out, and sine over cosine is tan. So my 3/4 is going to equal tan alpha. And there's a really important point. I've combined these 2 equations, and now I can work out what alpha is by doing tan to minus 1 of 3/4 So like my inverse tan, that's going to give me alpha, which if I put that into the equation, let me just double check, we want that in degrees. So I put my calculator in degrees and do 10 to the minus 1 of 3/4. And that gives us 36.9 degrees. 36.9 degrees. There we go. And that's it. So now we found alpha. And then the other thing we need to do is find r. And once you get used to it, finding r is actually really, really easy. But I'm just going to do it the long way to kind of fully explain how it works. So basically what we're going to do is we're going to take these two equations and we're kind of going to square them both. So basically what I'm going to do is 1 squared plus 2 squared. Yeah. So when I do that, on the one hand, 4 squared and 3 squared, yeah, so this squared plus this squared must be exactly the same thing as r cos alpha squared plus r sine alpha squared. So that makes sense? I'm basically saying that 4 squared and 3 squared must be the same as r cos alpha squared plus r sine alpha squared. And then I simplify that. So I've now got 16 plus 9 is equal to r squared cosine squared alpha plus r squared sine squared alpha. Or in other words, 25 equals, and then I can pull out the common factor of r squared, cos squared alpha plus sine squared alpha, which importantly, this thing here is just 1. So actually 25 equals r squared times 1, which is just r squared. So yeah, so 25 equals r squared times 1, which means we can square root both sides to find that plus or minus 25 equals r. And basically, I know there's like a positive and a negative root there, so r could be positive 5 or negative 5. But the key thing to remember is that when we do these, we always take r as being more than 0. So actually, in this case, r is going to be positive 5. So now we have alpha and we have r. The shortcut way for this, though, is basically to take the 4 and the 3, square them both, add them together to get 25, and then square root it. Like, you don't really need to do all of these steps every single time because this will always happen, it'll always cancel out as 1. So this is the shorthand way, just do 4 squared and 3 squared, get you 25, square root it. But I want to show you the proper way. And then, last thing we need to do is just plug r and alpha into the equation to get our answer. So, we were going to try and write it in this form here. So, instead of writing r at the beginning, we write 5. And we've got cosine of 2 theta minus 36.9, because that's our alpha. And that's it. That's the answer. So we've now rewritten all of this to look like this. And that may seem like a lot of work for nothing, but the idea there is that this is just simpler to work with. Like if you had to draw all of this on a graph, that'd be really hard because you've got a sine and a cosine function combined. Whereas this here is relatively easy to plot on a graph. And also just solving it and generally working with this expression is a lot easier. So that's why we do it. Anyway, I hope that makes sense. If you have any questions about anything, let us know down in the FAQ. And otherwise, we'll see you in the next video. Thanks.